Current changes to the global geopolitical map are being fueled by struggles between world powers for control over strategically important logistical communications, corridors, staging areas, and potential markets. One important area of this struggle are the planet's oceans, and the key competitors are the United States, China, and Russia. These state actors are reassessing the competition, rethinking military doctrines, and establishing new responsibilities for their armed forces. Of special importance is the development of naval capabilities equal to the tasks set before them. Each of the three main competing powers have their own aims, which come from their specific geopolitical position, economic potential, and unique considerations of national security and cultural strategy. In the last several years, following Russia's return to the world stage as a power to be reckoned with, Moscow has significantly revised its approach to challenges and threats. As part of this work on new strategic plans detailing the character of Russia's naval presence on the high seas, the Maritime doctrine was updated and then approved on July 20th, 2017. The main threat to Russia was identified as the efforts of a number of states, primarily the United States of America and its allies, to dominate the oceans, including the Arctic, and to establish overwhelming naval superiority. The Atlantic is of special interest to Russia due to the increasing economic, political, and military pressure from NATO countries and the consequent sharp reduction in Russia's capacity to project power in the region. Additionally, Russia's political and military leadership are striving to strengthen the armed forces in the strategically important Mediterranean and Black Seas, which also have repercussions on the Atlantic. The main priorities of naval policies in the Arctic region are to maintain the Russian fleet's access to the Atlantic as well as to safeguard exclusive access to the rich natural resources of the continental shelf. The Northern Fleet plays a vital role in defense of the state and continued unhindered economic development. The importance of the Pacific for the Russian Federation is also huge and continues to grow. The Russian Far East sits on enormous resources but is sparsely populated and largely isolated from the industrially developed regions of the country. This situation is aggravated by the intense economic and military development of neighboring states in the Asia-Pacific region, which has a strong influence on economic, demographic, and other processes in the region. One area previously ignored in the Maritime Doctrine, but which was included in the revised version, devotes attention to Russia's shipbuilding capacity. The inclusion of this section in the doctrine is due to the critical situation of the naval construction industry and the physical state of the military and commercial fleet. For example, the doctrine estimates that in order to maintain a shipping volume of 1,129 million tons, it will be necessary to build 1,470 cargo ships with dead weight of 22.9 million tons. Furthermore, 1,069 vessels will need to be scrapped and replaced due to aging, and 401 vessels will need to be built in addition to that which exists today. The doctrine describes how the ability of Russia to effectively react to challenges and threats requires a significant strengthening of the Navy and a presence on the oceans. In order to defend its interests, the Navy requires a minimum of 2 full-fledged aircraft carriers, one in the Arctic and the second in the Mediterranean. This says nothing of the large number of surface vessels which could be needed for other sea zones. The deployment of an aircraft carrier in the Pacific would only be possible in the distant future. So far, it appears that surface groups deployed in distant sea zones are being folded back into existing groups closer to home. The new doctrine emphasizes the capabilities of naval aviation in relation to nuclear strategy. Without air cover to deal with the likely superiority of enemy anti-submarine aviation, it is impossible to guarantee not only combat readiness, but also the deployment of submarines with their ballistic missile payloads, which form the main nuclear strike capability of the Russian Navy. Missile-carrying vessels and shore-based surveillance aviation, as well as anti-submarine aviation, would be unable to successfully go into action without fighter cover. Fighter cover is necessary for the combat efficiency of large ships. In turn, surface vessels make possible the deployment and safe return of submarines from combat areas, as well as the movement and deployment of paratroopers. The surface fleet plays a defining role in building minefields as well as mine-clearing operations. Traditional uses for surface vessels include launching strikes on enemy objects within their own territory, defending shorelines from enemy naval forces, and engaging in anti-submarine operations. In these ways, surface vessels perform a number of critical functions on the battlefield. They can carry out these functions independently, in groups, or in coordination with other naval forces like submarines, carrier-borne aviation, and the Marines. Due to the important role played by the Navy in Russian power projection, the Navy and the surface fleet in particular are faced with many critical challenges which must be addressed today or in the nearest future. While the Russian Air Force and submarine fleet are equipped to meet their particular challenges, the surface fleet finds itself in a complex and even paradoxical situation. In order to analyze the condition of the surface fleet, it is necessary to survey the current line of surface vessels as well as the construction and modernization plans which are part of the government's rearmament strategy. In the second half of 2018, the Russian Navy's surface fleet, a nuclear battle cruiser, 2 Project 1164 missile cruisers, 3 Project 956 destroyers, 7 Project 1155 destroyers, Project 11540 frigate, 5 Project 1135 frigates, and a Project 22350 multi-role frigate, which were in service and ready to carry out operations. At the same time, the Russian Navy's submersible fleet had 11 nuclear submarines with ballistic missiles, 6 nuclear submarines with cruise missiles, 7 nuclear submarines with missile torpedo armaments, and 20 diesel submarines in service and ready to carry out operations. It is clear from this information that the Russian Federation's surface fleet is not ready to carry out its obligations according to the Maritime Doctrine at 2030. In reality, it is one strike group which has been spread from the Atlantic to the Pacific. It is unable to react to threats in an effective and timely manner. In order to gather these forces in one combat theater would take a month at minimum. Expecting the surface fleet to fulfill its responsibilities under the Maritime Doctrine 2030 is unrealistic. It bears mentioning that a large part of the fleet has aged and modernization, given economic realities, is doubtful. Let's look at how the development of the surface fleet will meet the challenges specified by the rearmament program. About 4.7 trillion rubles has been appropriated for the Navy's modernization from 2011 through 2020, with an additional 2.6 trillion rubles designated for the Army. These plans call for entry into service of 10 Project 955 missile cruisers, 10 Project 885 nuclear submarines with cruise missiles, 20 non-nuclear submarines including 6 Project 636.3 diesel-electric submarines, and 14 rebuilt Project 677s. 14 frigates including 6 Project 11356 and 8 Project 22350s, 35 corvettes including 18 Project 2380s and 2385s, with the others being anticipated future versions. This construction program is the most ambitious rearmament since the fall of the Soviet Union. The State Rearmament Program 2011 to 2020, GPV 2011 to 2020, includes a construction program for a coastal fleet, designed not only to defend Russia's shores, but also to defend Russia's interests in deeper waters. This program is the only area in which there has been no progress made under the Maritime Doctrine to 2030. The GPV 2011 to 2020 is turning out to be entirely unrealistic, both in terms of construction capacity and the ability to finance these projects. In 2015 and 2016, it became clear that the budget and military-industrial complex were inadequate and that additional funding for the GPV is impossible. The revised GPV 2018 to 2027 determined that each branch of the military would receive roughly the same resources. It also takes into account Russia's actual shipbuilding capacity and emphasizes work on submarines and smaller vessels like corvettes and frigates. A key point of the naval part of GPV 2018 to 2027 will be the construction of coastal vessels armed with cruise missiles, strategic missile submarines, and lastly, multi-role submarines, to be developed in that order. In this way, the new GPV addresses both open and closed seas. The Project 23,000 Storm nuclear aircraft carrier was not included in GPV 2018 to 2027. In May 2018, a source in the Russian Navy explained that a concrete decision on development of a new aircraft carrier and preparation of the project's documentation would begin in 2019. It is possible that this aircraft carrier could be laid down in 2021 or 2022, and preliminary estimates say its construction would take about 10 years. Blueprints indicate the vessel would have a displacement of 80 to 90,000 tons, a length of 330 meters, a beam of 40 meters, and draft of 11 meters. It could carry up to 90 aircraft and 3,000 missiles and bombs. Which company would build the project has not been indicated. By the most optimistic estimates, work could not begin earlier than 2022. The Project 23560 Leader destroyer finds itself in a similar situation. Unlike the aircraft carrier, all work on this project has been postponed until after 2025. In January 2018, a source in the Russian Navy explained that technical and design work on the Leader is set to begin after 2020, with construction of this lead ship to begin in 2025 by the firm Severnaya Verf, St. Petersburg. The vessel will have a displacement of about 17,500 tons, length of 200 meters, a beam of 20 meters, and a maximum speed of 32 knots. Leader's armament will include 60 anti-ship cruise missiles, 128 guided missiles, and 16 anti-submarine guided missiles. Severnaya Verf is planned on building 2 helicopter carriers and then beginning construction of the destroyer. Development work on the helicopter carriers will begin in 2018, with construction beginning in 2020 and launch set for 2024. There are several main reasons causing the gap between plans and reality in GPV 2011 to 2020 and GPV 2018 to 2027. Personnel. It's not a secret that the Navy suffered more than other branches from the fall of the Soviet Union. The Navy today has a serious manpower shortage. The average age of its staff is 55 to 57. 30% of its specialists are older than 60. There is a major lack of personnel between 35 and 45. The shortfall in technical engineers in the industry is at 17%, construction engineers at 22%, and specialists in a variety of fields up to 40%. By way of comparison, the aviation and tank industries did not lose their personnel between 1990 and 2000, and they fulfilled their obligations under GPV 2011 to 2020 and are fulfilling them under GPV 2018 to 2027. This is due to export orders worth billions of dollars. This allowed personnel to be maintained, occasionally factories modernized, and cooperation between corporations in the industry continued. Military shipbuilding of anything significant for the surface fleet more or less came to a halt during this period. Modernizations and technical services were continued for exported ships, but this clearly was insufficient to allow the Navy to fulfill its GPV requirements today. Industrial capacity. Since the collapse of the USSR, the Russian shipbuilding industry has not produced anything on the scale of the Project 23560 Leader. Neither the USSR nor Russia built a full-fledged aircraft carrier. The industry, which already has a lack of experience, could encounter problems which would lead to long delays in production. These issues are not visible during the planning phase. The initial planning for the Project 23560 Leader destroyer did not take very long, which is the only source of optimism to the Naval Command. New issues may arise in the near future during the engineering design phase. Among other things, difficulties should be expected in the planning and development of specific components. Issues in this project, which could arise in a number of areas, negatively reflect on the entire destroyer building program. Issues with the armaments and electronic systems cannot be ruled out either. Added to the fray could be the search for a suitable location to build the Project 23560 lead ship and others of its class. Few Russian shipyards are equipped to build such a large vessel, and existing capacity is already back-ordered for the next several years. As a result, the Navy and military-industrial complex will have to plan the construction of large vessels around the industry's current and future abilities. Funding. According to a number of Russian experts, the process of creating a single aircraft carrier would cost 350 to 400 billion rubles at 2018 evaluation. Including the aviation component and group ships, the price tag passes 1 trillion rubles. Cost of reconstruction of existing industrial space for building large naval vessels would be astronomical, and Russia does not have the money, nor will it have the money in the near future. Technology. A number of critical technologies for building an aircraft carrier in Russia today are lacking. There is no shipborne aviation with long-distance radars, shipborne anti-submarine aircraft, or sudden takeoff and vertical landing aircraft even under development. It is possible to do these things, but it would cost additional billions of rubles and years of R&D. Engines. As long as engineering work on ocean-going vessels has not even started, it is pointless to talk about the power plant for destroyers or aircraft carriers. There is more hope for the Russian fleet to produce gas turbine engines for smaller surface vessels, and the future construction of large ocean-going ships depends on their successes in this. According to information from the Rybinsk manufacturer Saturn, they have built at least 4 M90FR engines for Russia's Navy and 1 for testing. Furthermore, 2 gas turbine engines for the last 2 Project 22-350 frigates are already complete and are awaiting the delivery of reduction drives. The company has also built at least 3 M70 FRU engines which are presumably for the Project 11356 frigates. Despite this, some Russian experts doubt the operational readiness of these first of their series gas turbine engines, as prototypes still need to be tested. It is likely that the delay in the completion of the Project 23560 is due to waiting on the results of government tests. Challenges in the areas of organization and planning. After a delay of several years, the refit of the only Russian aircraft-carrying cruiser Admiral Kuznetsov began. It is planned to be undergoing this refit and modernization from 2018 until 2020. However, the condition of the Russian shipyards is such that there is a risk of serious delays similar to that which plagued the nuclear missile cruiser Admiral Nakhimov, which was supposed to return to service in 2012, but which in fact began its refit in 2015 and may not be completed until 2021. Out of the large ships undergoing a refit and modernization in this decade, only the missile cruiser Marshal Ustinov completed the process successfully, and even at that, a process which was expected to take 3 years ended up taking more than 5. Furthermore, the modernization work was limited, especially if you don't count the radar outfit. The PKR P-500 Basalt was replaced with the more up-to-date, but still developed during the Soviet period, P-1000 Vulcan, while the other armaments stayed the same. Bases and resupply points. Another difficulty of developing an ocean-going fleet with an aircraft carrier is that Russia lacks a network of military bases overseas like that which supports US naval power. Of course, these open-sea ships have a great deal of autonomy, but on long voyages, they still need to take on new stores of water and food and make routine repairs. The Russian shipbuilding industry is the most troubled out of the entire military-industrial complex. Its number of failed programs is as bad as that of the space industry, keeping in mind both its military as well as civilian parts. Unfortunately, the current state of military shipbuilding does not engender optimism. With the exception of specific companies, the industry as a whole is in a crisis, which leads to catastrophic delays in the majority of programs. To remedy the deficit in personnel in the military-industrial complex will take years. In the last few years, the Russian leadership has encouraged development in this area through the setting of legal norms and the training of new personnel. This comes in addition to legislation about education in the Russian Federation and a presidential order from October 14, 2012 on increasing the ability of the state to support worker organizations in the defense industry. It's important to understand that resolving any given problem in planning or construction will require specific specialists. In other words, decisions have to be made now about what kind of fleet is needed and then how many and what kind of specialists to train. Even if these processes are successfully realized, training the necessary personnel for an area will take years, if not decades. A number of specialists investigating various ways of solving these problems in the industry are taking into account the Korean experience with building large ships like supertankers and supercontainer ships. Korea took a path of intensive scientific and technological progress and implementation of innovations in shipbuilding. The main risks with this strategy are from the development of knowledge economy, or more to the point, from the rate of growth compared to the rate of production of the main competitors. It demands not only the uninterrupted import of technology from abroad, but also the development of a scientific and engineering base inside the country, especially for construction of large, specialized purpose open sea vessels, where the amount of imported technology is large. The work is just a question of assembly, and the Korean companies played a minor role in the actual development process. The reality of Russia's position today disallows this sort of strategy, particularly for the construction of a modern navy. Shipyards certainly will not be able to find space before the end of this decade, more the construction of the Project 23560 Leader destroyer, to say nothing of building an aircraft carrier. Possibly for this reason, the country's leadership and naval command decided not to hurry the process. It makes sense to study the engineering and construction decisions made on analogous enemy ships and prepare the technical response in Russia's own ships in order to level the playing field as much as possible. In this case, it would be better to invest in research and technological development such as missile systems, strike coordination systems, and unmanned aerial vehicles. At the same time, existing systems should be modernized, and if resources allow, ships of whatever type can be built over the course of 7 or 8 years. Following on this, it would be reasonable to begin the development of just one series of frigates. Concerning the propulsion for the proposed aircraft carriers and destroyers, it may not make sense to develop a gas turbine engine from scratch for these types of ships. Warships in distant waters with gas turbine engines would be extremely reliant on refueling. For the US Navy, which has a network of bases and supplies, this is not a problem. However, the Russian Navy would be better served by building ships with nuclear propulsion. For example, the KN-3 TRR-KR reactors from the Project 1144 Pyotr Veliky were developed on the foundation of icebreakers, OK-900 reactors. Today, next-generation RITM-200 reactors are used for the new LK-60YA icebreakers, Arktika, Sibir, and Ural. They are lighter and more compact than the OK-900, but operate for 3 times as long and use 80% as much fuel. It needs to be refueled every 7 years, as opposed to every 2 or 3 like the OK-900, using civilian 20% enriched uranium. However, it never needs to be refueled using more heavily enriched uranium. Probably the entire military-industrial complex is practical applications for the RITM-200 reactor, so with modifications it could be installed on the destroyers. The first icebreaker sporting the type of propulsion system should enter service in 2019. Speaking of existing gas turbine engine models, the implementation of their mass production is one example of successfully and quickly replacing Ukrainian production. Another example of fairly quickly developing domestic capacity was the production of VKHD water-water coolant systems and the MKHD water-oil coolant systems. Russian diesel engines are constantly becoming more reliable. In 2017, the Kingisepsky machine building factory officially announced the launch of the diesel family M50 and M500. According to the results of a comprehensive audit, the company presented the necessary technological processes in the manufacturing of components for marine engines of various sizes, including the CHN 1820 and CHN 1617. In this industry, it is much more important to develop the processes, modernization, and construction of diesel engines for ships of smaller displacement. Balance needs to be found between constant regulation of the industry and, at the same time, maintain competitive conditions. The first half of this can be accomplished with the establishment of a center to monitor the industry, which will process details about the pace of work and fulfillment of government defense contracts. This type of control would provide alerts about problems and allow for additional material and financing to be directed at those issues. Simulating competition in the industry is a much less familiar task for the Russian military-industrial complex. Today, the industry is essentially a monopoly, and naval command lacks influence over it in the case of delays or quality issues. Increasing competition would prevent situations like a practically finished ship not being put into service because its engines are faulty. As for bases and supplies, some historically active bases could be reinstated with some countries in Africa and Southeast Asia. Considering the preceding analysis, the Russian surface fleet is currently unable to effectively realize the demands of the Maritime Doctrine to 2030. This is due to a whole series of problems such as the lack of personnel, the loss of industrial capacity, and the lack of a space in which to build aircraft carriers and other large ships. On top of this, the condition of fleet is itself deteriorating. The remedies applied by the Russian leadership have not been enough. Following the logic in GPV 2018 to 2027 and the actual condition of the Navy's surface fleet, by 2030 Russia could lose components of the fleet which are able to independently and effectively act on open seas. Of course, as a branch of the armed forces, the Navy will still exist, but the maximum which could be expected would be the defense of its own bases and parts of the Russian coast, with demonstrations and seas close to Russian territory. Furthermore, the ability of the Navy to carry out one of its most important tasks, the deployment of naval strategic nuclear forces, would be put in doubt. Nuclear and diesel submarines deployed without surface cover are defenseless and blind. On the other hand, there are many signals that the military and political leadership clearly understands these issues and how things stand in the Navy and place high importance on the development of naval power. The Russian leadership is planning to develop the fleet for asymmetrical containment using modern 21st century technology, like that which President Putin recently unveiled to the world. These plans include automation of manned and unmanned naval systems, unmanned surface ships and submarines, modern torpedoes and missiles, and weapons based on the new principles of physics. Concerning the ocean-going surface fleet, technical redevelopment of shipyards, training of personnel and specialists, and R&D on potential projects will all have to be waited on. Only then can the modernization of the fleet really begin. Therefore, for the foreseeable future, the surface fleet must defend Russian waters with corvettes and frigates. To discuss a growing Russian naval presence on the high seas in the near term would be premature. The surface fleet could at most carry out one campaign or one extended tour on the oceans. The situation that meets this definition right now is the Navy's deployment in the eastern Mediterranean Sea as part of the Syrian intervention. An effective presence on open seas will not be possible earlier than 2030, and only if current naval funding and other defense programs are maintained at their current levels.